All right, hello everybody. Thank you, Karina, for setting us up for this presentation. Thank you everybody who joined in today for the call. Today we're going to be talking about adaptive network automation, and a lot of what we're going to be sharing are things that were discussed at Cisco Live in Barcelona a couple of weeks ago. So some of you on the call may have been at the event and talked to us already. Some of you might be joining us for the first time. So we'll use this opportunity to share some of the insights that we learned at the event and share a little bit of how we're seeing the need for network automation evolve in enterprise networks. As Karina said, if you have any questions throughout the webinar, please use our Q&A window. To kind of set the scene, we're going to really talk about the need for network automation, particularly within network operations. And this slide here kind of addresses some research that Gartner did in 2018 and 2019 about the most time-consuming tasks within network operations. You can see 33% identifying and troubleshooting network issues, according to respondents, and 30% detecting and remediating security threats. So these two things together represent about 2/3 of all time-consuming tasks within network operations. And really, I think of this as firefighting, responding to network alerts, responding to network incidents. And the cost of an outage within network infrastructure is typically about $300,000 per hour. So not only is it the most time-consuming task, but also these tasks are critical in nature and time-sensitive. So the question is, why is now the time for automation? We have been managing enterprise networks a certain way for really decades now. Typical troubleshooting incident response has been very command line, sort of manual driven. Why is it so important that today we begin to adopt automation if we have survived so long in the industry, doing things just fine so far? So really one of the things that's driving that is new technology adoption. It's driving the urgency for adopting automation within networks. And the reason there are a couple. This new technology adoption is driving a lot of complexity. So I'm talking about software-defined networking and software-defined WAN, the move to public cloud. Networks are no longer able to be really managed end-to-end by any one person. They're just too complex with just too much specialization and knowledge. So this leads to the second point. There's really a knowledge gap. So the folks who are designing these network infrastructures, maybe bringing on ACI in the data center, or Viptela on the WAN, or moving to Azure, AWS, the network architects that are bringing on these network infrastructures and these technologies are not the only folks that need to know how to troubleshoot them. It's really the entire network operations team who needs to respond to network problems. And in order to do that, they need to have the same level of knowledge about their network infrastructure as the people that designed it. And this is not happening fast enough, and that's why there's this knowledge gap. So these two things, the complexity of the networks, the knowledge gap that's coming on with the new technology adoption, is really driving urgency for these operational challenges, the things identified in the previous slide: troubleshooting, security, responding to threats. So if the vast majority of the team doesn't have the knowledge to handle the complexity of these complex hybrid infrastructures, then the time it takes to respond to issues is going to continue to increase. And in fact, that's what we're hearing. So this slide is meant to take a look at what's happening within a network operations center every single day. How many tickets are teams facing? So you can think on the call, how many network incidents, network alerts, network alarms, security events, network changes, how many of these are happening within your environment every single day? And what's the nature of that incident response? How long is it taking? For very large and complex network infrastructures, they might have thousands of network alerts and security events, hundreds of trouble tickets from tools like ServiceNow or VMC Remedy every single day. So the scale of the volume of events and alerts and tickets is another reason why we are needing automation. When you see this kind of scale happening in your environment, this is a ripe for automation. And yet, network automation so far has really focused on day zero and particularly day one network operations. So really on the configuration and deployment of network infrastructures. So typically when network teams are thinking about network automation, they're really focused on technologies like network configuration and change management, SDN for provisioning, and things like that, maybe Ansible, of course. All of these automation technologies are focused on the configure phase, the day one operations. This says nothing of all the things we've talked about so far, the day two operations, operating, upgrading, securing, troubleshooting network infrastructures. And this is where we need automation to really step up. And this is a complex problem to solve, and this is what we're here to talk about today. NetBrain Visibility Automation is meant to fill in this gap where the majority of tasks today remain highly manual, troubleshooting and security response, and the volume has just become untenable. So we're going to talk about a methodology to apply visibility and automation to your incident response workflows today, whether it's a troubleshooting workflow or a security response workflow. And we're going to outline a three-step process to do that. Step one is really to discover and decode the entire network infrastructure end-to-end. Have an understanding of the underlying network, whether it's a traditional network, an SDN network, SD-WAN, or moving to the public cloud, it doesn't matter. Network teams need to troubleshoot the networks end-to-end because they don't know where the problem is. So you can't have silos. In fact, you need a total end-to-end visibility. So how do we tackle this challenge when different technologies require different levels of expertise? What you need is a solution that has an understanding of the entire network, a discovery and modeling engine that can absorb information from your hybrid infrastructure, and of course, the way that you collect information from different parts of the network is unique. So for example, with your traditional network, to mimic a typical troubleshooting workflow, you need automation that can leverage SSH and CLI and SNMP. And so in fact, that's how we collect NetBrain. We collect data from the traditional network. If it's the software-defined data center, SDN, SD-WAN, or ACI, NSX, Viptela, the way data is collected from these infrastructures is different. They're a lot more modern infrastructures. They leverage APIs typically to SDN controllers. So the data model needs to understand how to absorb data from SDN networks. And then as we're moving towards cloud like Azure and AWS, this end-to-end visibility automation solution also has to be able to read data from the cloud. By doing that, what the system needs to do is create a mathematical model of the underlying network and all of its underlying complexity so that the engineer who is responding to incidents and alerts has all of the information they need at their fingertips, regardless of what part of the network they're troubleshooting. And so what this allows is three things. So one, on the top right here, mapping the hybrid or the heterogeneous infrastructure in a single view. This image here, a little bit small, hard to see, but the example here is using ACI, Cisco SDN, and also extending into the traditional network from the leaf devices. But you can basically map any part of the network and extend your visibility out from that point. Number two, the end-to-end path. That means when you're troubleshooting a slow application, you need to understand how traffic is flowing for that application. What are the network dependencies across the traditional data center to the SDN data center, across the cloud, into the public cloud where maybe the application is being housed. You need that end-to-end visibility, and you need end-to-end path that can calculate that visibility dynamically. And then the third thing that you need is to be able to leverage these, we call these the NetBrain dynamic network maps, dynamic network visibility, to not just as a reference document, but as your troubleshooting and automation interface. And so you need to be able to automate diagnostics on top of these maps. And by pulling data from your entire network and having this underlying data model, the value of that model is to be able to create these multiple views and deep diagnosis and analysis of your network dynamically. So we're going to kick off with a live demo of what this looks like, end-to-end visibility and automation for hybrid networks. And for that, I'm going to introduce Chris Lopez to run some live demo.
Hey everyone, I'm Chris Lopez, and this is going to be NetBrain's introduction to end-to-end visibility across hybrid infrastructure, including SDN and cloud operations. I'm going to pop into NetBrain real fast. So as Jason mentioned, NetBrain is collecting data from each device, and it's building a comprehensive data model of the network, which is being used here to map our heterogeneous network. Mapping functionality here is not just focused on one sector of your network, but it's the entire scope of it. Right here we can see remote branches. We can see wireless technologies, SD-WAN, a traditional data center, even software-defined data centers, and even down to public cloud. For software-defined data centers, we do support Cisco ACI, VMware NSX, and we also talk to VDS or vCenter as well. Recently, we just developed our support for public cloud. started with AWS. As you can see from this section here, we're covering different types of gateways from AWS and different kinds of connection methods to Cloud VPC. Inside of the Cloud VPC, we don't only visualize the cloud-native services like the VPC router. We also visualize the connection between cloud-native services and the virtual services running in the cloud, like your CSRV, your virtual firewalls, and your virtual load balancers in the Cloud VPC. This is the first benefit that you're going to see from using NetBrain, to map out your hybrid network in a clear, methodical way to demystify your application dependencies as they move through different vendors and technologies. The next element that we want to show you is end-to-end visibility between any two IP addresses or DNS names within your network. So we've executed a path analysis, right, by just including the source and the destination here at the top. If we take a closer look into the example that's on this map, we're going to see that we started from a remote host in a branch office. We went through a Viptela SD-WAN, through a traditional data center, and all the way to through an ACI environment and through a VMware NSX sensor, finally ending at an ESXi host here on the right. All of these hops are calculated by NetBrain, and they're based in the control plane modeling that occurs during discovery. That means that this end-to-end path doesn't require any live traffic in order to be generated or to verify if the application even works. So this gives you more visibility into your applications and their associated dependencies without taking up too many resources from your devices. It's also important to note that any end-to-end path can be used to generate maps for your organization. Now, on each kind of map, including this path map, we can further execute actions and other kinds of diagnostics within NetBrain's environment. These actions could be executing CLI commands. They could be overall health monitors or running some kind of automation task that can help decode and catalog your network design for future use. As we can see here, these features from NetBrain give you the ability to customize your own executable runbooks, which can then be saved for reuse by other members of your organization. Our philosophy is to facilitate knowledge sharing between senior engineers and their junior counterparts, and this is especially useful in modern environments, where new technologies are going to create knowledge gaps and learning curves that are going to impact your ability to respond to and investigate problems. And in this sense, NetBrain helps you manage all of your devices effectively from a single pane of glass. Now, to show you how these maps are dynamic, I'm going to go ahead and build one from scratch real fast. I'm going to pop into this environment here. So this is obviously a blank map. We've just discovered our entire environment here, and we can see that we're looking at legacy devices. We've imported data from our hypervisors, from our SDN nodes as well, and we've turned our entire environment into a searchable index, like a Google search for our network. And to begin, I'm going to go ahead and start typing in a host name. We could be matching with an IP address or a MAC address, or even just part of a configuration file. But I'm going to type in boss core. So any devices that match that naming convention, boss core, are going to pop up in the search bar here. As I click in, we see allowed device details that are pulled on a periodic basis, and we also see all of the immediate neighbors, everyone that's attached to boss core demo, the router that I just selected from the search bar. I'm actually going to go ahead and open up this map. So here, as I mentioned, we see boss core demo. We see we're attached to MPLS cloud. We're attached to a firewall. And after we go through a DMVPN, we're also attached to our LA branch office. And let's say that's what I'm doing here. I want to document my LA branch office, which could have a variety of different technologies in it. All I need to do is click on this red plus, and I now see all of the neighbors that are attached to LA WAN 2, even if they're not currently represented on the dynamic map. And once I add them to the map, they appear like so. Now, this isn't just limited to L3 topology. If I wanted to, I could actually isolate L2 topology. I could isolate technology based on interfaces or sites, and I'd be able to add those to the map in the same way. I'm going to go ahead and change the auto layout real fast. And the idea is that no matter what the type of infrastructure, if I needed to go into my ACI underlay, or if I needed to go into any NSX dependencies, or even even hypervisors, I will be able to do so from this from this red plus, from this extend neighbors, because NetBrain is going to analyze and allow you to display all of your devices in the same way. So here, in terms of decoding network design, we would actually use automation tasks for that. So over here, I'm going to start running things called data views. These are just containers of device information. They're expressions of NetBrain logging into each device executing show commands, and then visualizing that data for you directly on the dynamic map. And I'll start with device information, and we'll be able to see how NetBrain has classified each of our devices into routers, firewalls, and switches. And we can also see the serial number, the version, and the model appear beneath each device. They are called dynamic maps because, not just because we can extend neighbors at will, but as we zoom in, we're going to see more and more information appear on the links between each device. If I hover over this routing protocol, then we'll see the part of that configuration file that informs where this information is coming from. And if I wanted to do something and highlight all of my OSPF protocols, I could do this. I could do the same thing for routing protocols. I could do the same thing for MPLS or multicast. I could do the same thing for contract views. I'd be able to do the same thing for any policies that may exist on NSX, or to be able to pull up all of my existing VXLANs. Again, NetBrain is going to pull all of the data from the control plane of these devices, and you'll be able to visualize that for you directly on a map. And all devices here are going to be treated equally. So with this in mind, NetBrain is going to be able to provide you end-to-end visibility across your entire hybrid network, and we'll be able to give you a little bit more insights than you'd be able to find without it. All right, I'm going to pass this back off to Jason. He can take us into the second part.
Cool, thank you, Chris. That's great. So now that we've had end-to-end visibility of the network, now that we've been able to decode the underlying network design to understand different aspects or attributes of the network for maybe for troubleshooting or for network design with the data view technology, the next thing is to look at how we can augment our existing workflows with this visibility and with automation. And the workflows we're talking about here are the ones that I talked about at the beginning of the presentation, really those incident response workflows. So to do that, let's look at a typical incident response workflow, almost like a case study of what happens every time a problem comes in. At the beginning, really, we highlighted those 4 circles on the left, the number of network alerts, security alarms, trouble tickets, and changes that are happening every single day. So we know that faults are detected of some kind or another on the network hundreds or even thousands of times a day. Let's take one example. When there's a ticket, what typically happens is before a first response engineer opens that ticket, there's typically some time that's lapsed, right? Maybe there's an issue in the middle of the night and it takes a couple of hours for an engineer to respond, or maybe the engineer is just so bogged down with the other, 100 tickets that day, or the team is bogged down that it just takes, maybe several hours to respond. So number one, time delay, idle time. The next thing that happens is, yes, the first response engineer is going to open that ticket. Oftentimes, these first response engineers are at a help desk or the network operations center, and they may be less experienced at the more advanced parts of the network. They're not typically architects or senior engineers that are the first response teams. So this team might have a basic set of diagnosis that they perform, and if they don't find the problem with that basic set of diagnosis, then what do? They have to escalate. They escalate to a senior engineer, to level 2, to level 3, to an architect. And then this time, now we're adding more time to the process. There's inefficiencies in the escalation. More teams have to come in. They have to understand what's been done. We might be getting into 2, 3, 4, 5 hours at this point before we even find what the problem is. And at this phase, we really call this, not just time to repair, mean time to repair, but it's mean time to identify the problem. So we call that TTI, time to identify. Ultimately, of course, every time a problem is found, maybe it just takes 2 hours or even 2 days. So ultimately, now we're moving on to remediation. It's time to deploy a fix and verify that fix, repair the network, fix a slow application, for example. And then after that's done, there's typically this concept. Sometimes it's just a concept. It's not actually put together in practice, called the postmortem review. The purpose there is to understand what went wrong, how can we avoid this from happening again, and how can we do better next time. Using the example, it took 6 hours to troubleshoot this issue. Maybe it ended up being a silly issue in the end. The question is, how do we make sure it doesn't take 6 hours the next time this happens? How do we codify lessons learned and improve this process? So we see this, when we talk to our customers, we see this as a typical workflow happening hundreds of times every single day, perhaps. So we see there's opportunity to augment this with automation. And at NetBrain, we look at 3 phases of automation that we can augment this workflow. For number one, looking at the idle time, we think we can eliminate that idle time and reduce that to 0 with what we call triggered automation. Triggered automation, at the moment a ticket is created, at the moment a network alert or an alarm is detected, a first response automation is triggered via the system, by the machine, by an API call, in fact. And what that first response does typically triggers a dynamic map of the problem area, like you saw in Chris's demo, and typically performs a first response diagnosis automatically. And we'll talk about what this looks like in action with the live demo in just a minute. The next phase of automation is, triggered automation might not find the problem, right? There's 1,000 things that could go wrong, and maybe the diagnosis checked for the top 10 most likely issues, but we didn't find the problem. Automation can still help when people arrive on the screen, on the scene. And in fact, that's sometimes the most important time for automation. We call that interactive automation. That's when engineers are driving diagnostics through an automation console like NetBrain, using concepts like data view, like Chris showed you, to collect and analyze data in real time, rather than doing that one device at a time through the command line interface. Instead, doing that across multiple devices, leveraging automation to look for potentially a dozen data points or a dozen potential hypotheses at a time. Call that interactive automation. And then the third phase of automation is really answering the question, how do we do better next time? How do we take the troubleshooting process that maybe took 4 hours, even with interactive automation, and how do we codify lessons learned, make those lessons executable, and feed those lessons back? We call that shifting the workload to the left towards the first response engineer or towards first response automation, shift the workload left towards these teams, enabled by the lessons learned from every single outage, captured in typically a post-mortem review. And you can codify those lessons learned with automation without any scripting. So how NetBrain is going to do this, we'll see in a live demo in just a minute. Really, there's 3 underlying technologies. We talked about one of them on the bottom here, the data model of the entire network, how NetBrain collects and analyzes data across hundreds, thousands of data points for every single device in your network, builds a mathematical model of the network. That model is the foundation for automation and visibility. We saw that in Chris's demo. The foundation for visibility, like we saw, is the dynamic map, the dynamic network map. You saw how Chris created these maps dynamically, for example, through a search, or for example, by specifying a source and a destination IP address and asking NetBrain to map that path. And you saw how dynamic map is used to visualize any data. Next, we're going to talk about the automation side. Executable runbook is a technology we use to scale automation across teams, and not just scale automation, but scaling what automation to do. Because we're talking about troubleshooting, we're talking about tribal knowledge, knowing how to respond to incidents in real time, knowing what to look for. So a runbook is the way that you codify those lessons into an executable format. We call that an executable runbook. So these 3 technologies are the foundation for NetBrain automation, what we call adaptive network automation. So with that, we're going to kick off our second live demo to Chris Lopez to show us what this looks like by integrating automation into our existing workflows.
Hey again, guys. So here I'm going to start showing how NetBrain can integrate with existing tools in order to provide more automation solutions and get rid of a lot of that idle time that currently exists in your troubleshooting process. So here I'm going to begin inside of my ticketing system. This is ServiceNow, and from here I'm going to spring NetBrain into action using a couple of details that I'm putting into this ticket. Here, I'm identifying a business service that's being impacted. I'm identifying a configuration item that's associated with this business service. And I'm also giving the description, in the description, I'm giving the IP of the user that's calling in and the nature of the issue, which is video slowness. So I point out down here, I would like to point out that there is, we have a NetBrain automation tab inside of our ServiceNow instance, but currently it's empty. It will be empty until I submit this ticket. So from here, NetBrain is actually beginning to, or it is currently executing this, this first response automation. So right now, it's going to create a just-in-time map and a just-in-time diagnosis that's executed on top of that map at the moment that the incident is created. I also want to point out that this could also happen with an alert from a monitoring tool or from a SIM or from anything else that tells you that there's something wrong with your network. So here back at the ServiceNow ticket, I'm just going to go ahead and refresh this real fast. We're going to be able to see that 2 maps have appeared below. So we're going to see a lightning bolt map, which is our crime scene map. So using the business service that I specified up here and using the IP of the user that was calling in, NetBrain has been able to generate a map of the critical path of all the devices that exist between point A and point B, which is loading right now. And this is the trouble area, right? This is the area that your engineers are going to need to focus on in order to resolve this issue. And this is something that might have taken you a long time to find out manually. If you had to start from the user's IP and kind of log into each device along the path in order to figure out how what path it took to get to the business service, here NetBrain's done that for you automatically. So also from here we have a number of data views, like you saw in the last demo, that we can execute on top of this map. So I'm going to go ahead and execute an overall health check directly on top of the crime scene map. All right. So as we zoom in, this is I'm going to point out that this overall health check is looking for common indicators of performance issues, such as CPU, memory utilization, input errors, and output errors. Really things that would obviously be wrong with your device if there was some kind of a performance issue. But as we can scroll along the map here, we can see that there don't appear to be any red alerts. We can look at all the processes on each device if we really want to. But right now, we don't have any kind of violations here. But just having this map and having this initial triage represents a lot of the work that goes into troubleshooting some kind of incident. So I'm going to move on to the second map now. This is the siren map. This is what we call a known problem map. So this is based on the configuration item that I specified here. When I submitted this ticket, NetBrain started searching for all maps that were related to this configuration item. All known problem maps that were related to this configuration item, and it's been able to pull up any existing problems that were there on this part of the network before this incident was created. So here, looks like we have a CPU bug triggered by high CPU utilization on PIM-RP. It seems that that this was a problem that we had to deal with previously, and the known effective releases for this device, which is a Cisco iOS device, is 15.2.2 and 15.2.371S. And if I look at the live data that I pulled from this device, we can see that the software version is actually 15.6, which is tipping me off that we have patched this issue already. So I could go ahead and just start typing in things like, looks like we've patched this already. And I'd like to point out that here at this stage, we're going into first engineer automation, or when the first engineer hops into the on-demand map and begins executing interactive automation on top of it. So we can see how this is a reduced human touch in that I don't need to go into every single device to begin executing a number of show commands in order to get the results that I've just seen. I'm letting the machine doing it for me. And also here, since I wasn't able to find any obvious issues, I'm going to need to escalate this to another engineer. So I could go ahead and just type in, at network team, could you please take a look at this? And I could raise attention to this, meaning that once I post this note and I raise attention, this will be the first note that anybody sees on this map. So in this sense, this is really helping us with that escalation aspect. So this map becomes a collaboration hub for all of our activities. And no one needs to duplicate the same efforts that I have just been executing on top of the dynamic map in order to continue troubleshooting. They can just pick up right where I left off. So here, let's say that I'm now a network engineer who's hopped in to look at this. I'd be able to just execute other data views that currently exist inside of this bar just to do some more diagnoses. So if let's say I would run a QoS monitor, and then we can see that we are actually losing, we're experiencing some traffic drops here on show policy map interface. And that might be the reason why we're having some kind of video slowness with our Cisco Telepresence app. So here I'd be able to say, I'd be able to give the help desk team a indication like, hey, this is what's wrong with the network. We're going to be upgrading the QoS policy. And here we would go into remediation, where I use the map as a change interface, and I also use it to verify that the QoS policy has been upgraded by the time that by the time that everyone can see it inside of the ServiceNow instance. And finally, there's one other thing I would like to do, which is a proactive automation, where I would take this map and I would save it as a new known problem map, meaning that the next time that we have an issue with this part of the network, we're going to be able to see not just this one map. We'll be able to see the second map here that tells us that we had a QoS issue, meaning that even if I don't take care of this in the future and I'm not familiar with this part of the network, other engineers can benefit from my know-how and my experience to be able to either rule out common issues that exist on that part of the network or to identify them immediately. All right, and in that sense, NetBrain helps you with baseline improvements, and it's also going to help us with runbook enhancement as well, since they'll be able to see all the tasks that I've been executing on top of the map when I was going through these issues. All right, and with that, that's what we wanted to show in terms of NetBrain using automation to improve your troubleshooting flow. I'm going to go ahead and pass this off to Chris Villamay for the final part of our demo.
Hey, thanks, Chris. Let me go ahead and take over here. All right. So we're going to talk about now how we can shift workloads to the left, leveraging the concept of adaptive automation. So again, focusing on the concept of proactive automation, in other words, taking those lessons learned and converting the lessons into automated diagnostic procedures so that next time we can resolve a similar issue much faster. So again, keep in mind, this is the stage Chris Lopez just finished up discussing. This is where we're going to build continual improvement with our automation processes based on what we experienced in resolving an issue. So again, the goal of the escalation engineer is to record the diagnostic steps that enable them to reveal the root cause of a problem, and then ultimately convert these steps into a process that can be automated and executed at scale should a similar problem occur. So we covered a bit of the data model, and I just want to highlight here again, just to reiterate, the data model, it grabs a lot of pieces of information. Again, it's not just configuration. We build a full topology, we grab various telemetry, state and condition information, and then we enable some really powerful analytics, such as being able to baseline that data and compare with historic values and build contextual relationships. So, as we know, day two operational tasks are of course unknown and unpredictable. We don't know what problem we'll face on any given day as a NetOps engineer. So the trick here is how to build an automation platform that can handle the unknown. So keep in mind, with or without network automation, to solve these day-to-day NetOps tasks, engineers will always require configuration, topology, and network telemetry. These tasks typically, in the absence of automation, would be performed using a combination of static documentation, manual device-by-device telemetry gathering, and a hypothesis-based troubleshooting approach to divide and conquer until root cause is isolated. Instead, by leveraging NetBrain's robust data model, we can apply an analytics-driven methodology using a baseline-driven troubleshooting approach rather than hypothesis-based troubleshooting approach to guide problem investigation and to automate incident response. So keep in mind here, this is, we discover and model your total environment. We track, baseline, and analyze thousands of data points across your environment. And this powers the automation and visibility for day two operations and incident response. So let's now take a look at a short demonstration of how we can leverage this data model and NetBrain's analytics to provide proactive automation for every problem investigation. So we'll begin with adaptive automation to illustrate implementing increasing levels of automation and enable ultimately the shifting of workloads downstream, reducing escalations, and with the biggest goal to reduce MTTR continuously over time. So if you see here in this slide, we're going to look at how we're shifting the workload, shifting that knowledge to the left, right? So I'm an escalation engineer. I've received some ticket. My goal here is to, of course, record these diagnostic steps and ultimately solve the problem and record those steps that were used to solve this problem, so that in the future we can get to root cause much quicker. So let's jump over into the NetBrain environment, and I can show you an illustration of that. So let's assume we've got this ticket that came into the help desk. Again, I'm the escalation engineer. I've picked up this ticket. There's very little to go on except for a slow video application, and then I have a source and destination IP. So we're going to leverage the NetBrain platform, quickly pass this out. And again, this is something that can take an engineer, potentially in a complex environment, it could take 30 minutes to an hour just getting this hop-by-hop set of operations and path. So this, as you can see here, this is doing this in seconds. This is already saving me huge amounts of work. So now what we want to do is, of course, I'm going to do some troubleshooting. So So I know this is a video problem. I'm going to start with my main primary multicast router, what we've got named here as PIM router number 4. So I'm thinking perhaps this might be the candidate for beginning my troubleshooting. So I'm going to do my standard types of operations. I'm checking CPU. I check interface statistics. But really what I want to do here, let me go ahead and save this map. Really what I want to do here is take this diagnostic and document that I've done this. So for example, I checked a look at CPU, I took a look at interface statistics, but I know as the senior engineer that our tier 1 team is often forgetting to check the transceiver. So again, we've got a batch of these SFPs for our optical interfaces in our environment that we've seen a higher than normal failure rate. So I know to check this. Now, of course, on this particular router, I don't find any problems, right? So I can see here all these are not in alarm. So it looks like so far this guy looks healthy. So what I'll do is I'll go ahead and document the results of my diagnostic into NetBrain. So again, we see here that we've documented these values. Just a note here, of course, as you see here, these are been, per our data model, we've already converted these values into a variety of variables, what we refer to as parsers, and I'll show you a little bit more of that in the future here. But what we're particularly interested here for the optical interface is the optical transmit power. So again, I've got these series of diagnostic commands, but really what I want to do is try to do this a little quicker. So let's go ahead and add another step here. I'm going to execute some additional CLI commands. And we've got a nice little template kind of mechanism here just to make this a little easier. So I'm going to go ahead and load this. And again, as you can see here, what this is doing is show proc CPU, show interface, and then of course the transceiver check that I know our tier 1 team is often forgetting to check. So the nice thing about this is a very basic level of automation, but I'm running these 3 commands across these 4 devices. Multi-threaded, so it's doing it in just a couple of seconds. You can see here I've already got these values, right? And of course, if I go through here, I can check the various outputs. And so far, it looks like everything is good until I get to this output here. And I can see here that we do have the interface gig 01 is in an alarm state. So we've isolated the issue here with this diagnostic. We need to replace this piece of hardware, right? But this is likely causing a soft failure, some packet loss, and is likely the cause of our problem. So let's jump back in here to the presentation and show you kind of the next step. So again, that was a relatively simple example of a low level of automation, taking 3 commonly run diagnostic commands, saving them as a batch file, and then running them against several devices at once using NetBrain's multi-threaded functionality. But really what we want to do here is do more than just list commands in a batch file. For this purpose, we can leverage NetBrain's data view template technology. And combined with NetBrain's powerful data model and network baselines, we're able to empower level 1 engineers to handle senior engineer level diagnosis. So again, the beauty here is that data view templates provide that one-click automation mechanism, enabling our junior engineers to obtain all the diagnostics I just showed in the last scenario, but obtained in seconds with the click of a button. So again, let's jump back over here to our lab environment. And I'll just show you an illustration of what this would look like. So again, on the same map right here, if I wanted to apply, let's say, a basic health check. So again, what this is doing is this is checking the outputs of CPU and interface and overlaying that on the map. It's checking this live right now. So you can see this is actively ongoing and checking all these outputs for these various devices. And once it completes here, it will allow us to display that on the map. And you see here, we have a wide range of data views. There's a lot of built-in ones, but ultimately the goal is to customize the data views that are going to be relevant for your environment in a particular scenario. So again, here we see a lot of very helpful telemetry pieces of information obtained by those parser variables that I showed you briefly are overlaid on the map. So if we look at how this is actually constructed, so this is the Yeah, okay, so if we look at how this is actually constructed here, we see that we can mix and match these variables. So now the nice thing about here is I've taken variables from show interface output, as well as some the values that you get from the show interface's transceiver, and I've put them in a single data layer so that when I layer this on the map, I'm able to see all of these analytics, all this telemetry in a single place. So let's go jump back over to our presentation here. Oh, and one thing I just wanted to mention, really one of the big values of DataView template also is that, and I'll show an illustration of that here shortly, is that we're able to put in a recommended action section. So again, just to show you that real quick, if we jump back over here, or jump back over to our map, we actually have a recommended action here, right? So this is something that, as part of this health check, this would have been previously defined. So as senior engineer, I say, hey, go ahead and run this health check, but if you don't find the problem, here's some next steps, some additional suggestions, right? So, okay, so again, now that we've created a useful set of diagnostics with our DBT, leveraging these parser variables that you can see here, again, let's just show you briefly how this works. Keep in mind we've distilled all of these features, all these command outputs, and distilled this down to a list of defined parsers, right? So local AS number and prefixes received. These are all things that we can track and take action upon. So this is also fully customizable as well. So again, we've created this useful set of diagnostics with our new DBT, but our goal as senior engineer is to make this DBT available to our junior level engineers as a recommended action that I mentioned previously. So within their standard health check, they'll have some next step suggestions as to how to continue that troubleshooting process. So let's take a look at another scenario to demonstrate this method. So let's assume I've previously mapped this path out. I've got another slow application, in this case with our SAP business application here. So again, I've got this fully mapped out here end to end, and now what I want the Tier 1 team to do is to run this health check that I've provided for them. So we'll go ahead and apply this device and interface health check. Again, what this is doing is checking the output of show proc CPU and show interface. And ultimately, we'll reflect on the map if there's any interface drops or anything that violates our previous baseline calculations. So this is the sort of task that every engineer is going to have to start with, right? I mean, no matter what the network problem is, you need to know, am I dropping packets? Are any of the platforms in the path running high CPU or some other negative condition, right? So we see here this looks clean. So we already know that the issue is not with CPU or something that's apparent with this basic health check. So what we want to do now is apply this as apply the recommended action suggestion of the transceiver DBT. So again, we'll go ahead and run this. And immediately we see that we found a golden baseline alert. So again, we can zoom in here. So note this is the exact same problem that we looked at before, of course in a different path, different part of the network. But again, we have a baseline violation. So in other words, when the NetBrain system last checked the optical transmit power for this interface, it was not in this alarm state, and now it is. So we can see here very clearly that this is again, resulting in soft failure and of course, ultimately gonna cause packet loss. So again, in summary, NetBrain's DataView templates enable that engineer to know three things. What has changed? Is my network in a normal state or is it in a deviation? And what should I do next? So this enables a powerful analytics-driven and automation-assisted troubleshooting methodology. So let's jump back into our slideshow here and take a look at what we can do next with automation. So again, we've seen increasing levels of automation applied to incident response. But NetBrain's philosophy is that no human should begin a problem investigation until automation has first done its job. This is the concept that Chris showed you previously with triggered automation to enable the machine to isolate the problem area and perform the initial diagnosis at the moment of the event or ticket creation before that engineer is even on the scene. So again, to illustrate the scenario, we'll jump back into our lab environment. And I'm going to show an integration, the same integration that Chris showed you with the ServiceNow, but I'm going to use it for purposes of showing how we've done this full shifting of workload and knowledge, all the way left in this case, all the way over to the machine. So again, this is a ServiceNow ticket, and we previously submitted this ticket, but the purpose here is that when we parse out this business service and fields from this description, NetBrain has been predefined to trigger a map as well as an initial diagnosis. So we can kind of scroll down here within the ServiceNow ticket. That's one of the nice things about this particular integration with ServiceNow is you don't even have to leave the ServiceNow ticket to see this info. So again, we can scroll down here. We see that we've got the same map that we looked at previously, and of course, a golden baseline violation. In other words, I've seen something that was not this value previously, and now I'm seeing it has changed. In this case, it's obviously a problem in the sense that the optical transmit power for that SFP is an alarm state, diode or some part of that interface hardware is obviously failing or going bad. So again, this is the final stage and our goal of automation, right? This is moving all of that workload to the machine. And in this case, it actually was able to isolate the issue so that when the responding engineer opens up this ticket, we see that triggered automation has not only done a ton of work for that person, for that engineer, but it's actually isolated the issue. Hey, so that concludes my demonstration. Let me hand this back over to Jason here to kind of wrap up.
Cool, thanks, Chris. And just by way of mentioning that integration that we've shown a couple of times now with ServiceNow is just an example. You can achieve a similar integration with other ticketing tools, maybe BMC Remedy or other solutions. And in the case of ServiceNow, we happen to have a free app in the ServiceNow App Store that makes that integration virtually plug and play. So you can see how you can basically continue to shift that workload to the left through automation. So just to wrap up, this is the last slide of our presentation, really talking about what does a NetOps automation model look like as it sort of is adopted within potentially your organization, and how is that driving automation maturity. This is a slide that we created actually sort of out of inspiration from what the journey is towards self-driving cars, as the human does less driving with things like adaptive cruise control and lane assist, all the way towards maybe one day where we can remove the steering wheel completely from the car. What does the self-driving journey look like from level 1 driving to level 5 automation? Similarly, we see a similar automation journey with network automation. On the left side, fully manual, very CLI driven, typical traditional network documentation. On the right side, you can imagine a world, maybe one day where there's full autonomy and self-healing. That's a little bit more visionary, but there's actually a journey in between these two extreme states. And this is just kind of a view of what that might look like, right? Kind of recapping some of the things we talked about. How you can, maybe level 1 automation is automating your documentation and assisting with your troubleshooting automation with some of the concepts like the A to B path mapping and automatic data view collection and things like that. You can imagine a level 2 automation where more and more of the expert level know-how through your existing playbooks or through every troubleshooting event is sort of codified into your executable runbooks. But maybe humans are still initiating the troubleshooting, they're still leveraging those runbooks, so there's still a lot of humans involved, of course. You can imagine as you shift further towards automation, right, we're beginning to trigger that automation like we showed a couple of times with the ServiceNow app, how you're auto-initiating your troubleshooting, but maybe in many cases, of course, it still does require a human to drill down, right? There's thousands of possible things that could be wrong, and automation may not be able to check for all of those. But you can imagine continuously over time how every sort of unknown problem eventually becomes something that's an unknown problem. Really, there's nothing new under the sun. It's really just a matter of discovering it. Once it's discovered, you can create a known problem diagnosis for that, and you can automate that. So over time and over a continuous adoption of this methodology, you can continuously drive down that mean time to repair where, towards zero-touch troubleshooting automation. And so this is meant to be kind of maybe an inspirational slide of a journey towards automation to ultimately reduce mean time to repair within your organization. So with that, we're going to wrap up our presentation. We'll keep the line open if you all have questions, or rather, submit those questions. We would ask you through the Q&A panel on your Zoom. And for some of those questions, we may take them over the phone as well. Otherwise, thank you so much for joining us today, and make sure you have a good day. And if you'd like to learn more about NetBrain Automation, maybe see a live demo, you can visit us at netbraintech.com and request a live demo with a specialized sales engineer. Thanks again.
Our team is now in the process of reviewing all the questions we received to decide which one makes sense to answer the line. And meanwhile, if you're interested in a custom private demo to learn how NetBrain can address your projects, please request an online demo on our website. For any customers on the phone, don't forget NetBrain offers extensive free online training classes. Talk to your account executive to get access to NetBrain University.
There was one question about is NetBrain able to integrate with monitoring tools. I think one of the things Chris Lopez mentioned earlier in the presentation was it doesn't have to be a ServiceNow ticket that's triggering automation. So maybe this question relating to this monitoring tools like PRTG, SolarWinds, CA Spectrum. And in fact, we do have two ways that we can integrate with those types of tools. One could be a triggered automation like we talked about. So every time there's a monitoring alert from a monitoring solution like that, it can trigger NetBrain diagnosis, just like we saw from ServiceNow. The other way that you might want to integrate your monitoring solutions with NetBrain is you can actually use the NetBrain map, the dynamic map, to absorb data from those tools to help you automate your diagnosis and collect data from your monitoring tools. So what does the monitoring tool say in terms of packet loss, performance diagnostics, and things like that? Rather than having to leap from NetBrain to multiple tools, you can pull that data into the map via API and use the map as what's called a single pane of glass. So those are the two typical integrations that we see with monitoring tools. So keep those questions coming in. Thank you. There was a question about that CLI tool that you saw in Chris Villeme's demo towards that third demo piece. We were using that command line tool, and someone noticed that we have that button called Document to NetBrain. So I think the question's around that tool. Is that a typical PuTTY window? That's actually a NetBrain kind of a NetBrain add-on. It's a separate download file, but it's really just a CLI session. And what that does is it just allows you to uniquely, use it like a typical CLI tool, but document your CLI output directly to NetBrain for the purpose, like Chris said, of documenting your workflow and basically documenting your expertise. And one of the fundamental things that we try to do is we try to augment your existing workflows as much as possible, rather than asking you to change those, right? So if you're using the CLI, we have a CLI tool that can integrate into your existing workflows. If you're using a ticketing system like ServiceNow or BMC, we can integrate automation into that workflow. Similarly, if you're using Ansible to make changes and you can actually integrate Ansible change automation into the NetBrain change automation workflow. We talked about monitoring integration. So whatever tools you're using today, the vision is to integrate NetBrain visibility and NetBrain automation into those existing workflows. And so that CLI tool is another example of that. Good question. All right, so that's what we see. If you have any more questions, feel free to stay on the line. We'll answer those over Q&A, but we're going to close out the live hot mic right now. Thank you again so much for joining us today. Hope you're interested in what you saw, and we look forward to connecting with you in the future. Have a good day.